Hello, everyone. This is Mr. Minnick. Today, I'm joined by one of my Algebra 2 classes, and we're going to get started with a quick overview of the cyclical nature of I. I is cyclical. If you watched part 1 of this video on complex numbers, at the very end of part 1, we talked about the cyclical nature of I, and really all we need to look at are the first 4 powers of I. I to the first power, by definition, is the square root of -1, which is just equal to I. Okay. So what I would write down in my notes, if I'm taking notes on this, is I to the first is equal to I. Okay. Also, if we move on to the next power of I to the power of 2, that's going to be the square root of -1 times the square root of -1, or the square root of -1 squared. When you square a square root, those inverse operations cancel each other out. So what we end up with then is -1. So if I'm taking notes here, what I'm going to write down in my notes is that I to the power of 2 is equal to -1. One thing that's very noteworthy, -1 is real. I is not real. Okay? So think about that as we go through this. This is not real. This is real. Okay. Moving on to the third power of I to the exponent 3 is equal to I squared multiplied by I. And that's because of the exponent rules. So if we think about what I squared was, well, that's -1, and I is I. Well, I guess I squared times I to the first. So that's -1 times I, which is -I. So again, if I'm taking notes, what I'm going to put in my notes is that I to the exponent 3 is equal to -I. If we think about whether that's real or not, that is not real. So you might make an observation, maybe you see it now. Hey, the first power and the third power of I are not real. What do you suppose the fourth power of I is going to be? Real. Check this out. So if we go I to the fourth, this reminds me of SpongeBob SquarePants for some reason. And SpongeBob's nemesis, well, not so much his nemesis, but his neighbor who he gives a hard time all the time. This Squidward. This is I squared times I squared, or I squared squared, which is -1 squared. When we square a negative, it becomes a positive, and -1, the quantity squared, is equal to 1. So again, if I'm taking notes, what I'm going to circle in my notes with a heart or maybe a star is that I to the fourth power is equal to 1. And that, as we assumed or suspected, that is real. Something very interesting happens. Check this out. When we go over here to the fifth power of I, it's going to be I to the fourth times I to the first. Okay? What's I to the fourth equal to? 1. And 1 times anything is just the anything, right? If I go to I to the sixth, it's going to be I to the fourth times I squared. I to the seventh is going to be I to the fourth times I cubed. I to the eighth is going to be I to the fourth times I to the fourth. So all of these are going to be 1 times something, and 1 times something, and 1 times something. Do you see what's happening here? Do you see it? 1 times I is just I. And 1 times I squared was -1, so that's going to be 1 times -1, which is -1. And this is going to be 1 times -I, which is -I. And this is 1 times 1, which is 1. Do you see what we mean when we say I's powers are cyclical? It repeats over and over and over and over and over. And one thing we had mentioned in the other classes is it's real important when you think about the cyclical nature of I, how you get somewhere in the cycle. Let's try to find I to the 23rd power, okay? If we wanted to, we could count in the cycle. And we would do something like this. Well, here's 1, here's 2, here's 3, here's 4. I got to find out where in this cycle does 23 belong. 5, 6, 7, 8. I feel like I'm dancing. So in the cycle, where am I going to go to 9? For 9, where do I go? I go back to the beginning, right? So here's 9, 10, 11, 12, 13, 14. There's an easier way to do this. It involves multiples and division. What should we multiply or divide by? Or think of the multiples of one particular number. Not I, not 1. Somebody said it. 4. We want to think of 4's multiples, okay? Everything hinges around 4. Multiples of 4. In general, I to the 4n is going to equal 1, okay? That's a real safe shortcut to take. What I mean by this is if we have any multiple of I, if we have I to the 4th, if we have I to the 8th, if we have I to the 12th, if we have I to the 16th, if we have I to the 20th, if we have I to the 24th, and so on. Hopefully you get the idea what's going on here. Those are all multiples of 4, the powers, right? 4 times 1, 4 times 2, 4 times 3, 4 times 4, and so on. All of those are the same thing as I to the 4th, which is just 1. All those are equal to 1, every single one of them. So let's think about I to the 23rd then. 23 is not a multiple of 4, is it? But it's close. It's either it's either forward from a multiple of 24 or back from a multiple of 24, depending on how you look at it. 24 is a multiple of 4, right? So if we had I to the 24th, it would be here in the cycle. So I to the 23rd in the cycle, where would it be then? It would be where I to the 3rd is, right? So I to the 23rd power, then, if we evaluate that, that should equal the same thing that I to the 3rd equals, which is what? Negative I, okay? And our calculator will do that for us. If I'm using a TI Inspire, I got to use the right eye. The right eye's on the pi button, and my calculator is doing some really interesting stuff right about now. There we go. So I to the exponent 23 is equal to negative I. Okay. Let's try a couple more of these just to see this cyclical nature of I. Let's try I to the 412th power. Is 412 a multiple of 4? It is. So I to the 412th then should equal what? 1, because in the cycle, it falls in the same place as I to the 4th, as I to the 8th, as I to the 24th. So I to the 412th power, I to the 412th power should equal 1. And it does. Okay, let's try a couple more. Let's go with I to the 39th power. No, not 39, I lied. Let's go I to the 41st power. In the cycle, where does that go? Is 40 a multiple of 4? Well, 40 is. So 41, where do we go in the cycle? All the way back up to I to the 1st. So I to the 41st then should equal what? It should equal I. So I, well, let me just grab this one and change the 412 to a 41. So I to the 412th should equal just I. And if we check it out, it does. Okay. Does that make a little bit of sense, the cyclical nature of I? Okay, cool, good. Well, today then what we need to talk about are a host of things. There's seven ideas. Wow. Standard form of a complex number. We got to get that out of the way. So here it is. Standard form. It goes like this. A plus bi. Now I'm going to underline certain parts of this. The part on the left is the real part. The part on the right is the imaginary part. And it's kind of interesting. I mentioned before that the calculator will evaluate a lot of this stuff for you. So let me just bring up a complex number on my calculator here. Let me bring up the complex number 15 minus 9i, okay? If I take the math button on my calculator and I go to complex numbers, I said if I go to complex numbers on my calculator and I want the real part Okay, let's try this again. My smartboard and my calculator don't get along so well today. If I go to the complex part and I want the real part of 15 minus 9i, my calculator will give me the real part of that. What is the real part of 15 minus 9i? It's 15, so the calculator should return just 15, right? And watch. It does. Okay? If I take the imaginary part of 15 minus 9i, what should it return? Not negative 9, negative 9i, that whole thing. Or, well, I guess it is negative 9. I guess it is negative 9, okay? So part of it's the real part of it's imaginary part. Everybody doing all right? Okay. So if you had something like 3 plus 5i, that is in standard form, okay? If you had 3 plus 5i all over 6, that is not in standard form. In the exercises in the homework, they're going to want the answers in standard form. The good news is your calculator, when it evaluates these, will put these in standard form for you. If you had to put this into standard form, this is actually equal to 1/2 plus 5/6 I. That's standard form now. If you don't believe me, watch. You ready for this? Just watch. Check it out. On my calculator, I want 3 plus 5 I all over 6. Here we go. You need to, if you're using a TI-83, TI-84, you have to use parentheses. So I got to group my numerator, 3 plus 5 I, close that, divide that by 6, and my calculator returns it as 0.5 plus 0.8, 333333333 I. Well, if you didn't know this, the TI-83 has the capability of making something that should be a fraction, a fraction. Anybody remember how to do that? You press math, and the first thing that comes up is says, hey, let's make it a fraction. So math, enter, enter, and there it is. 1/2 plus 5/6 I. We doing all right? Questions? Well, there should have been 8 bullet points on that list because there's something else we need to talk about. The complex plane. Okay? The complex number plane. A while ago, we studied this thing with the x and the y. And that French person gave us this. This was René Descartes in the Cartesian plane with the x and the y axis. Well, the complex number plane is similar, but a little bit different. The difference is just in the axes and what they're named, okay? So the complex plane, in some of the exercises, you're asked to plot points. The complex plane has 2 axes, one of which is the real axis, and the other is the imaginary axis. And in the exercises, you're asked to plot a point. So let's suppose you're asked to plot the point. Let's plot the point 3i. Let's plot the point 3i. I said let's plot the point 3i. I'm trying to shake this up and make another one. Maybe it'll just be easier if I do this. Okay, there we go. So the point 3i, is there a real part to that? Is there a real part to that? There's no real part to that. So we always think of the origin as like our home base. So if there were a real part to that, it would tell us we have to do something on the real axis, but there's not. So there's only an imaginary part. Well, let's think of the axes, how they go. This is 1, this is 2, this is 3, right? But since it's an imaginary axis, this is 1i, this is 2i, and this is 3i. So when we plot 3i, all we do is just go up 3 on that axis, and that's it. That's where that point would be. Does that make sense? So let's look at another point. Let's this time try to plot the point -2 plus I. Okay? -2 plus I. So what's the real portion of that? The real portion's -2. So here we go. Here's -1. Here's -2. So the real portion says, let's march it to the left, to the left. And then what's the imaginary part say to do? Go up 1. So when we plot that point, it would be right there. Okay? It would be right there. Does that idea of plotting points make sense? Okay. Well, I should have had 9 bullet points. The absolute value of a complex number is the square root of a squared plus b squared. I love this one. I feel like Vince sometimes. Sometimes I wish my name were Vince. Seriously. Why? Vince is a cool name. Vince is a really cool name. So consider 3 plus 4i. If we had to plot 3 plus 4i in our traditional coordinate plane, it would be in the first quadrant. We'd have to march it over 1, 2, 3 over there, and 1, 2, 3, 4. So it'd be somewhere up there, right? Everybody follow me so far? So here's 4i, here's 3. Well, when we ask its absolute value, we want its distance. Its distance from, normally from 0, but in this case, what's its distance from the origin? Okay, that's what we want. We want to know how far is it from there to there. And there's a Greek mathematician that can help us answer this question, right? Who is it? Not Einstein. There's a Greek mathematician who can help us answer this. If we were to go like this, we'd have a vertical height of 4. We'd have a horizontal distance of 3. We have a right triangle formed. A right triangle formed. And we're really asked to find its hypotenuse. Thank you. A squared plus b squared equals c squared, right? Well, what we're after, this 3 is the a, this 4 is the b, we're after the c, right? So how do you solve for c? You take the square root. Do you see where that formula comes from? Oh, it's just the Pythagorean theorem. Solve for c, right? Do you see it? No pun intended. Do you see it? Do you see it? Okay, so if you know anything about geometry and special Pythagorean triples, you would already know the answer. If you use the formuolae, this is where people get this twisted. People get this twisted when they use the formuolae. So the absolute value of 3 plus 4i by the formuolae is the square root of a squared plus b squared. Let's try to identify a and b. So a is the real part. What's our real part? Our real part's 3, just the number 3. All right. What is our b? It's just the 4. Don't put the I in it, it's just the 4. Okay? So when we use this formuolae, we're going to have the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25. And what's that equal to? 5. Question. Do we need to put a plus or minus? If we solved a quadratic equation, we would have to, right? Are we solving a quadratic equation? I don't think so, Tim. We're asking for the absolute value. We're asking for the distance. How far is it from 0? Do we need a plus or minus? If you put a plus or minus, it's wrong. Make sense? Because distances are always positive. Is everybody doing okay so far? Would anyone like to hear a joke? Well, they don't pay me to tell jokes, so I'm not going to tell one. Oh, that was so wrong. That wasn't, you just can't do that. You just can't do that. Maybe I should tell that knock-knock joke. Knock-knock. Interrupting cow. Moo. Those knock-knock jokes are just, I don't know. I don't get them. Okay. Multiplying binomials. Here we go. Multiplying binomials. Multiplying binomials. Every time I think about, I almost wrote binomials. Multiplying binomials. Every time I think about multiplying, I think about Grease in the song Summer Nights. Well, maybe it's not that song. Maybe it's not that song. I got skills in multiplying, and I'm losing control. What song is that? You better shape up, do, do, do. Yeah, the one that I want. Yeah, nice. Good looking out. All right, cool. So multiplying binomials. Here's what Math Excel says to do, Math Excel says you have A plus BI times C plus DI. Math Excel makes a mountain out of a molehill. They say this is AC plus BCI plus ADI plus BDI squared. So they say this is AC plus BC plus AD, the quantity I, plus BD times -1. So they say this is AC minus BD plus BC plus AD, the quantity I. That's what Math Excel does. Don't make it that difficult. It's not that bad. Okay? You don't need to do that. Check it out. You're going to FOIL. You're going to combine like terms. You're going to replace I squared with -1. Combine like terms again. That's the way, That's the way you do these. If you had to do one of these without a calculator, by pencil and paper, that's how you'd do. You'd FOIL, combine like terms, replace I squared with -1, simplify, combine like terms again. So here we go. Example, 3 minus 2i times 5 plus 4i. Okay. So when we FOIL, we take the first terms, and what do we do with the first terms? A lot of people overlook this step in FOILing. What do we do with the 3 and the 5? Do we add them? We multiply them, because we've got skills in multiplying and we're losing control. So we take 3 times 5, and the product of the F part of FOILing is 15, right? And then FOIL, F-O, the outer product gives us, and we need signs, pluses and minuses, because this is polynomials and stuff. So this is plus 12i, right? The inner part of FOILing, it's a product, -2i times 5 gives us minus 10i, okay? So that's the inner product from FOILing. And then with FOILing, we need the last product, -2i times positive 4i is -8i squared. I hope everybody follows what I got going on so far. We're doing okay? So we FOILed. Now what? Combine like terms, okay? So we're going to have the 15 still the 15, but we have some like terms to combine, eh? What's 12i minus 10i give us? 2i, good. So we get plus 2i. And on the end, we have minus 8i squared, but you know what? That next step says, hey, we're going to replace I squared with what it's equal to. What's I squared equal to? -1. So we make a substitution. So what happens to -8 times -1? What's that become? That becomes a plus 8. Okay. So now we've got 15 plus 2i plus 8. Now the directions that I gave you that are a little bit different than Math Excel's say this. It says FOIL, we did that. It says combine like terms, we did that. It says replace I squared with -1, we did that. And then it says combine like terms again. Well, what terms are like? The 15 and the 8. So our final answer here then, when we combine the 15 with the 8, is going to give us how much? 23 and then plus 2i. Remember that these should be in standard form, okay? Remember, standard form. You got to put the answer in standard form, and that's what you'll get. So do you want the good news? The good news is I'm encouraging you, I'm promoting use of the TI calculators. You've got them, use it. It'll do this for you. Check it out. It's really cool, really easy. You just got to use the right eye, that's all. And you got to use parentheses, and you got to be careful with how you use parentheses. A lot of people mess this up. Parenthesis 3 minus 2, I, close parenthesis, open parenthesis, 5 plus 4, I. And there you go, 23 plus 2i. Isn't that a lot easier? Isn't that the horse's pajama? The cat's meow? The bee's knees? The dog's food dish? The dog's biscuit? My dogs don't like biscuits. My dogs like chocolate. They say it's not good for dogs, but my dogs are special. Everything's bad for you, right? Chocolate's bad for you. Butter's bad for you. Eggs are bad for you. Bacon's bad for you. I like talking about food. Okay. Are there any questions, comments, concerns about multiplying? Going once. Going twice. Sold to the lady in the second row. She's an 8, she's a 9, she's a 10. Okay. I'm not a country fan. No offense to anybody who likes country. Just not my kind of music. The old country, yes, not the new stuff so much. I do like that one song though. What is it? Cowboys and Angels or something? That's a cool song. Okay. Simplifying expressions. You ready for this? I do want to make this real clear. You're going to encounter 3 different types of examples that involve simplifying expressions. One goes like this. 2i times negative 3i times 4i. Okay, that's one example. Another example is 2 plus 5i minus 3 minus I. So we're going to look at 3 distinct examples, and then we're going to look at the quantity 2 plus 5i times the quantity 3 minus I. Okay, so let me just kind of cover that one on the end up for a minute, those ones. We'll just look at this for now. Those parentheses imply that we do some kind of operation. Multiply. Good. The commutative property says you can line up the numbers and the stuff in any order, right? Well, I like numbers. So what I've got, and so I don't forget about the negative, I'm going to put it out front. So I have negative 2 times 3 times 4 times, now let me pick up my variables. What variables do I have? I and I and I, right? Okay, well, what's negative 2 times 3? Negative 6, and negative 6 times 4 is negative 24. So I get negative 24 out front, and I times I is I to what exponent? I to the third. Hold up, wait a minute, Mr. Postman. I to the third, let's go back a minute. Let's go back. I to the third is equal to negative I, so we need to make that substitution. So I to the third is negative I. So what we've got is negative 24 times negative I. So what's that going to simplify to be? Positive 24I, right? Do you think your calculator will do this for you? You bet. Check it out. Watch this. 2, 3, and 4. Here we go. Parenthesis, 2. I got to get the right I. It's on the pi button. So 2i. Was it negative 3i next? I think the negative was with the 3, wasn't it? Okay. And then, whoop, got the parenthesis going in the wrong place there. And then 4, got to get the right I. Remember, get the I on the pi button if you're using the Inspire. And there we go. It gives you 24i. Lickety-split, just like that. Everybody okay so far? Okay, well, this happens when we take the pencil paper test. Not the same. These 2 problems here are not the same. We got a question. Can you use a calculator on a pencil paper test? There will be an upcoming quiz where you won't be allowed to use one, and there will be a chapter test where you will be allowed to use one. With Math Excel, you're allowed to use one. So you will be, I won't require you to do the really complex stuff by hand, but one like this one with the product here, I will expect you to do something like that by hand. Great question. Terrific question. So these other 2 problems we've got, I want you to realize they're not the same problem. They're not the same problem. What operation in the blue problem, what operation separates the 2 binomials? Subtraction, right? And the one on the right, what operation separates them? Multiplication. Everybody see the difference? I don't know why, but every time I give a pencil paper quiz on this material, people mess that up and they want to multiply the blue one. You're not multiplying the blue one, you're subtracting, which is simply combining like terms. We just combine like terms. So we combine this 2 with the minus 3. What's 2 minus 3 give us? Negative 1. And let's combine our other like terms. What's 5 minus I give us? 5 minus I. 6i. So negative 1 plus 6i is what you should get if you do this right. Check it out. Even my handy, trusty, faithful TI-83 will do this stuff. Here we go. 2 plus 5i minus 3 minus I. I said I, not decimal. And there we go, negative 1 plus 6i. Notice it gives you the answer in standard form every time. The real part, the imaginary part. We doing okay? Well. I talked to my friend TJ last night. I'm going to give TJ a shout out. It's weird that I have a picture of him on my computer. Some of my classes last year got to see him. Here he is. My friend TJ and I, the other day we were out burning a wood pile, and he loves Mountain Dew. Not as much as my manager from Radio Shack, but he loves Mountain Dew. And I grabbed him one out of the fridge and I threw it to him and hit him in the face. Good thing for him it was a soft drink. Oh, I've heard that one before. Okay, this problem on the end, just to show you it's not the same, remember we FOIL. So we FOIL and we get 6. We FOIL and we get minus 2i. We FOIL and we get plus 15i. We FOIL and we get minus 5i squared. So we get 6 plus 13i minus 5 times negative 1. That makes a plus 5 on the end, which makes 11 plus 13i. Remember, your calculator will do this. Know how to do one like that by pencil paper, okay? I will put one of those on an upcoming quiz. However, you are encouraged, and I promote the calculator. It's great. Use it. You have it. You paid $100 and some for it, or you're using the one that the school paid $100 and some for. Use these things. Where do I get the 6 from? 2 times 3 when we FOIL. Remember, when we FOIL, we multiply up first. So here we go. The quantity 2 plus 5i, close it, times the quantity 3 minus I, close it, and we get 11 plus 13i. Okay, everybody doing all right? Now, if you're watching the playback, you didn't see the little visitor we had drop in on the screen. My class might have noticed the spider that's joining us. There was a spider. Are there any questions, comments, concerns, short debates about any of those? Would we like to give any shout outs to anybody who might be watching at home? Anyone who's having a bad day gets a shout out. Happy Valentine's Day to Mason Butler. All right. Well, we had a lot of these bullet points to take care of. So let's go back and see if we missed anything, because I know we did. We talked about standard form. We talked about the complex plane. We talked about plotting in the complex plane. We talked about absolute value, even though those aren't bullet points. We talked about multiplying. We looked at simplifying, but now, now we have to look at simplifying rational expressions. Ooh. Simplifying rational expressions and this CCT go together. You can't do the one without the other. Wow. Here we go. This is not gonna be fun. Example. I hope I ate my mathematical Wheaties this morning. 3 minus 2i over 4 plus 5i. This right here is bad. What I need to do is get rid of that. There's this thing called the complex conjugate, and we're going to study this more in chapter 5, but the complex conjugate, a plus bi, and its conjugate is a minus bi. These are called complex conjugates of each other. Conjugates. It's kind of a weird word, kind of a weird name. If you multiply a complex number by its conjugate, it makes the imaginary stuff go away. Watch what happens. A plus bi times a minus bi. You don't need to write down all the intermediate steps, but do write down what that equals because it's going to be a shortcut. We're going to get a squared plus 2 abi minus b squared I squared. So that's going to be a squared. Oh, no, it's not 2 abi in the middle. Oh, this is great. This is a squared plus abi minus abi minus b squared I squared. So that's a squared. The ABI's in the middle go away. They drop out. They cancel. So we're left with minus b squared times, what's I squared? I squared's -1. So this ends up being a squared plus b squared. Oh, that's what you put in your notes. A plus bi times a minus bi is a squared plus b squared. That's called the complex conjugate theorem. And there's more to it than that. It says if something has a 0 that's a complex number, then its conjugate is another 0. And we'll talk more about that in chapter 5. What the heck does this have to do with simplifying this? You'll be glad you have a calculator when you see what all you have to do. You'll be glad you have a calculator when you see what all you have to do. Okay? Watch this. To simplify this, I need to multiply by the complex conjugate of this. What's 4 plus 5i's conjugate? If you don't know, your calculator will figure it out for you, but you should be able to figure it out based on the pattern we're seeing. 4 minus 5i, perfect, awesome, thank you, good looking out. 4 minus 5i, okay, 4 minus 5i. So what I want you to realize is in the denominator here, we can use this to get our denominator. What's our denominator quickly going to simplify to be? It's going to be 4 squared plus 5 squared, right? Everybody see that? Okay. So the numerator, and this is where people go awry and they get kind of frustrated. The numerator, what we've got to do is actually multiply that out. Oh no, this is going to take forever. So we get 12 minus 8i minus 15i plus 10i squared. So this is going to equal 12 minus 23i plus 10 times -1 all over 16 plus 25. So this is going to equal 12 minus 23, I said 23, 12 minus 23i minus 10 all over 41. So this is going to equal 12 minus 10 is 2. 2 minus 23i all over 41. But that's not in standard form. Do you remember the one earlier when I said we have to put it in standard form? To put this in standard form, then we'd have to go like this. It's 2 41sts minus 23 41sts I. That's our answer, if I did everything right. If you're using the calculator, watch. I'm going to make this full screen because I know there's about 7 of you that want to see the steps along the way. So if I'm using my calculator, here we go. I'm going to start, and this is so important. I cannot stress to you the importance of parentheses. I cannot stress to you enough the importance of the parentheses. Parenthesis, 3 minus 2i. Close it, divided by parenthesis. If you don't have the parentheses, it's going to give you the wrong answer. My calculator's dumb. No, it's not. You just need to put the right stuff in it. The calculator is not dumb. The calculator does everything it's told. Divided by the group of 4 plus 5. I. Close it. Here we go. Oh. It gives me decimals. How do I make decimals? Fractions. Math, enter, and there we go. Oh, that's so much easier. I am so glad that I'm using a TI calculator because all that crap that you just did a minute ago, I'm not going to do that. There ain't no way. I'm going to do all that. Where'd you get that from? Don't worry where I got that from. Use a calculator on these. Okay? We doing all right? I won't put one of these on a pencil paper quiz. Promise. Or at least if I do, it won't be. It'll be like a bonus type thing where you'll have a chance to get above and beyond a perfect paper. Okay? Any questions, comments, concerns, short debates about that? We have a question. At the top. The numerator when we FOILed, we got 3 times 4 was 12. Minus 2i times 4 gave us the minus 8i. The outer product, 3 times negative 5i, gave us a negative 15i. What ends up happening in this, let me get my magic marker, maybe this will help. This product ends up coming down here. Yeah. And then the denominator was the 4 squared plus the 5 squared. Yeah, as I was working through it, I ended up having so I had a fraction kind of the whole way through. Okay. So we have at least one more idea to talk about. 2 more ideas. 2 more ideas. You ready for this? Here we go. Multiplicative inverse. If we think about the number 2, we all know 2's inverse, right? What's 2's inverse? No, it's not negative 2. It's 2 to the negative first power, which is a half. Now, your calculator has an inverse button. Check it out. 2 to the negative first is a half. Oh, that's handy. If your calculator doesn't have an inverse button, here's what you do. To do this, we put 1 over 2. Okay? So if we wanted 7/8 inverse, we would take 1 over 7/8. Okay? On the TI Inspire, you might have to use that idea. What do we got? I forgot to see. Thank you. I wrote multiplicative inverse. Thank you. Good looking out. Multiplicative. Awesome. Thank you. That would have been pretty embarrassing if I had left it multiplicative. So are we ready to see a really fun example? Here we go. Find the multiplicative inverse of 3 minus 4i. So what we've got to do is this. We've got to put 1 over 3 minus 4i. But wait a minute. That's bad. That's not in standard form. So we got to multiply by its complex conjugate, which is what? Which is what? Come on, the complex conjugate of 3 minus 4i. Thank you, 3 plus 4i. So quickly in the denominator, quickly, what do we get? Remember the shortcut? Isn't it 3 squared plus 4 squared? The numerator, 1 times some stuff is just the stuff, so that's 3 plus 4i. So we get 3 plus 4i over 9 plus 16. So we get 3 plus 4i over 25. So we get 3 over 25 plus 4 25ths I. Wait a minute, that's a lot of work. I don't want to do that. I'm just going to use my calculator, right? What the heck did we start with? 3 minus 4i? Check it out. Parenthesis, 3 minus 4i. I want its multiplicative inverse. Oh, math. Let's make some fractions. Here we go. Yeah. That makes it easy, doesn't it? Using the TI Inspire. I don't know where the TI Inspire's inverse button is. So here we go. We started with what? 3 minus 4i? 3 minus 4i. If I raise that to the exponent -1, there it is. I think that's a little bit faster than doing it the old-fashioned way, eh? Are there any questions, comments, concerns, short debates, long debates? Real quick, there's 2 more things I want to show you. Simplifying the square root of -45. This is coming up in the homework. It's just like simplifying the square root of 45. We went over this skill several weeks ago. You need to find factors of the number whose product is the number and one of them is a perfect square, right? So the square root of 45 simplifies to be 3 rad 5. The only difference with square root of negative 45, it's 3 rad 5, but what happens? An I pops out. An I pops out, right? Remember that? That's going to come up when we solve equations like we're going to have on this last example. Last one of the day, I promise. Example. Solve. Oh, you know, it's a tough one when he gets it off a sheet of paper. 10x squared plus 9 equals x. 10. X squared plus 9 equals x. That's not in standard form. So we probably ought to put it in standard form, huh? So that's 10x squared minus x plus 9 equals 0. You have to put something in standard form to either factor it or to use the quadratic formula. A is 10. B. Some of you are identifying A, B, and C wrong. I'll have that quiz back to you tomorrow. Some of you are identifying A, B, and C wrong. What's my B value here? Thank you. It's negative 1. My C value here is 9. So x equals negative B plus or minus square root B squared minus 4AC divided by 2A. That song's so catchy. So negative 1 becomes 1, so we get x equals 1 plus or minus the square root of 1 minus a lot. 40 times 9, that's 360. That's 360 all over 20. So we get x equals 1 plus or minus the square root of negative 359 all over 20. We're not done. 359 doesn't break down. That's the good news. It doesn't break down any farther. It has no perfect square factors bigger than 1. It's not divisible by 4. It's not divisible by 9 because 3 plus 5 is 8 and 8 plus 9 is 17. It's not divisible by 9. It's not divisible by 4 because it's not even. It's not divisible by 5 because it's not, or 25 because it doesn't end in 5. It's not divisible by 36 because it wasn't divisible by 4 and 9. And there's no factors bigger than 1 that are perfect squares. Okay? So, what has to happen when we solve this then? Something's got to happen. An I pops out. So we get 1 plus or minus what? I square root of 359, still square root of 359, all over 20. And there it is. Math Excel, you'd need to split that up into 2. But that's it. We got it? We doing all right? It's been real. It's been fun. I hope everybody has a terrific day. See you next time.
Good.